let's trace some code that works with objects that have constructors and destructors. And this is going to require that we simplify a few aspects of our diagramming convention, although I'm going to use for this example the more formal style that you're used to. But I'll point out a few places where I would probably, when I'm tracing myself, and later in the course, simplify things, and where I think it's safe for you to simplify a few things when you're tracing. Because remember, of course, that the diagramming is just a visual device. It's about what makes sense to you. Okay, so I'm going to expect there to be a pretty decent amount of output here, so I'm going to represent it in two panes. Here's the first bit's going to come on the left, and then I'll move over to the right-hand side once I fill up the left-hand side. So I'm going to begin tracing. As usual, it's going to be the balancing act, try and find enough space to do this. I think I'm going to put main over here. And we'll see in a couple of minutes that there is a nested scope involved, and that's going to help us understand better the way that objects' lifespans and constructors and destructors interact. Okay, so there's main. I'm going to start on line number 20, and line number 20 is to generate this first freebie line of output. There we go, main 1. Line 21 says create an object of type fruit named A, and then call a constructor. So there are a couple of things to observe here. And one simplification that I think we can make in this case, that I'm not going to do, but that we could make, is calling a constructor is a function call. Therefore, we should draw a box in the diagram for the constructor call. You might observe that nothing interesting happens in the constructor besides generating output, so you can avoid doing that. I think you wouldn't need to draw the full box, but if you're paranoid about it, you should. And I'm going to do that just to follow through on my promise to be as formal and tedious as possible. So before I do that, on line 21, I'm going to create the shell for that object. It's going to be of type fruit. There it is. Okay. And its name is A. Okay, the second simplification I recommend is if we stare at class fruit, you'll observe that it has one piece of member data that's a name. And in fact, the thing I pass in from main ends up becoming that name. And so from later in the course, I will probably write, as a simplification, I'll say, well, okay, as far as I'm concerned, fruit is the word raspberry. It's not a string. I mean, I know it contains a string, but I'd be able to figure that out on my diagram. But to be formal, we will write it with the same verbose struct style notation we've been using. And if it were a class with multiple members, we probably still should do this. And we'll do it in later examples in some cases. But in this case, if there's only one member, maybe that's a reasonable simplification. So fruit contains a member called name. Okay, and name is a string. So there it is. It's a string, and its value is going to become, well, actually, I should be careful before I continue here. On line 21, when I'm initializing the object, I actually have to call a constructor. And that actually is a function call. I mean, we can see a parameter is being passed in. So I'm going to do this. I will simplify and not do this part next time we have to construct a fruit. But it's worth observing that when you call the constructor, you are, in fact, calling a function. So there's the fruit constructor. I'm going to indicate that it's the constructor on line 3. So I draw it a scoping box, and I set up its arguments. Okay, so its arguments are a string called the name. And it's a string, there we go, and it's set to raspberry. Okay, so that's what I need to call the constructor on line 21. Technically, that is what's happening. I am calling a function. And if something interesting were happening in here besides me generating output, I probably should do that because there could be scoping stuff, there could be exceptions thrown, I might care. On line 4, though, nothing interesting is happening besides generating output, so I probably would just not do this. I would skip this step, as long as I could keep track of things. But okay, we'll go through this step this time. So on line 21, I'm ready to now enter the call for the constructor. So I'm now entering line 4. I'm going to run the constructor. One thing we should understand is when I'm running that constructor, I have to remember to myself what object am I inside of here. So when I'm running the constructor, it's a member function. What object does it refer to? I don't really know an easy notation for that. I suppose we could just sort of indicate it's this one. It's this object here. This fruit object is the one I am constructing today. Because the members of the fruit object are, of course, going to pretend that they're in the local scope of the constructor. But they're not really local variables of the constructor. So you have to have some way of remembering that, of keeping track of that on our diagram. So maybe I just draw an arrow like that. Okay, so at the beginning, before we get to line 4, I guess I missed one more step here. Before we get to line 4, we have to finish initializing the members. And the first initializer, the only one, says take the value of the name and set the initial value of the member name to be that. So we would fill this in. All right, and then we run line 4. And line 4 prints out fruit constructor. And then it prints out the value of the name. So that would be raspberry. So the raspberry constructor. And as I mentioned at the end of a previous video, I think 2 videos ago, that normally the destruction order of objects is the reverse of the construction order within a scope. And we'll see an example of that in this later in this tracing. Okay, so I'm now done line 4. I've generated the output, and so that means this is done. The constructor ends, and so it's a function call, its scope ends, and I destroy it. And I think that's enough to conclude that I don't need to draw the box out next time I call the constructor. I get what it's doing. As long as I remember to generate the output on line 4, I shouldn't need to draw the box out in full. I can save myself that step. Okay, so I'm now done line 21. I've constructed my object Raspberry. We'll just clean up the drawing a little bit. I've constructed my object Raspberry, and the constructor's over. I've generated the output, and so I get to line 22. Here I am actually calling a function. Okay, and the function may be doing something non-trivial, so I will draw a full box for it. There's my function f. It takes as its argument a string, so it's called prefix. And there it is. And it's a string. And the prefix is the word grape. All right. And I've now set up all the arguments of the function. I'm ready to begin executing it, so I head up to line number 14. On line 14, I print F1. Okay. Line 15 says construct a fruit object, and I'm going to do that. I'm going to use the same long form notation that I used here. I'm going to just cheat a little bit and copy and paste this. Okay, so I construct my fruit object. Oh, it's not going to fit. Well, that's too bad. Maybe I won't copy and paste it. Okay, so I make a more compact fruit object. There it is in the scope of F. And it contains a string which is going to be its name. And it is going to be called, the name of the object is Z. And I recall from before how the constructor runs, so I know obviously that I'm going to need to run the constructor somehow, but I don't need to draw a box for it in the diagram. Before I do that, I have to compute the argument to F, the argument to the constructor here on line 15. Well, the argument is prefix plus fruit, so prefix is grape, so I'm going to pass in grapefruit. And I recall that what I pass into the constructor just becomes the name of the object. So I don't need to draw the box for the constructor because I've done it once and I've concluded the constructor is simple enough that I don't need to. But I do remember, of course, the constructor does print some output. So I print fruit constructor, and then I print out grapefruit. And I apologize in advance if my handwriting is bad. Try writing on a screen. But you can run the posted version of this code to both verify my work and to see the legible version of the output. So fruit constructor, grapefruit. And that's line 15, and then I end up with something like what I have on the diagram here. Line 16, I print F2. Okay? And then line 17, F ends. And here's where we need to be a bit careful. If ever I construct inside one of my scopes, any scope, not just a function, if ever I construct a smart object, so something of a class type, something that might have a destructor, I need to make a note to myself that when that scope gets destroyed, there are destructors to call. There are a few ways of doing that. One way you could do that is just sort of put an asterisk there, like mark the scope off as needing special treatment. So I do that. Every time I construct an object that needs special treatment, that may later need to be destructed, I can mark the scope as needing special treatment. Okay, so on line 17, what do I do? So what I do is the destructor for every object gets called before the object actually gets destroyed. It gets called sort of as the scope is being taken apart. Often the way I represent that, for reasons that might become clear to us a little bit later on, is I begin erasing the scope from the outside in. So I erase F here, keeping in mind that I'm not done erasing everything. So I'm not putting Z in the global scope. I'm just getting rid of things one by one. And then I destroy everything in the scope in reverse order of construction. So this was created second, so it gets destroyed first. There are two things in there. I destroy the most recently created one first. So Z gets destroyed. Now Z is an object of type fruit. Fruit has a destructor. So I now run that. It is a regular function, so I could draw a box for it on the diagram, but space is a bit dear right now, and because it doesn't do anything interesting, I think I can skip over that step. So I print out fruit destructor. And then it prints out the name, and the name is grapefruit. Later, we'll see that when I call a destructor, what I often do is actually pre-erase the box of the object, but I don't erase the members, because in the destructor, I can still use the members, and so I need to keep them on there. Okay, so now the destructor's over, and now I fully destroy the object for whom the destructor just ran. And now I destroy the other things in the scope. I mean, the string object actually has a destructor, but it's not part of this tracing example. It doesn't print anything out, so we can just get rid of that. And now F is actually over. So notice that this time, on the way out of my scope, I had a bit more work to do. Okay, and so then I'm back in main, and I ask the question, if 0 is less than 1. Okay, well, 0 is less than 1. So I'm going to open a new scope, and it's going to be the scope of, I'm going to call it if. There we go. And then on line 24, it says, well, create another fruit object. And just like before, I'm going to take a couple of shortcuts here. So one of them is, okay, I guess I still can't copy and paste, so I'll draw this in. This is of type fruit. And its name is going to be B. And its name, the name member of the fruit object, is pineapple. There we are. And let's see. The next thing I have to do is make sure that the constructor is being called properly. So I've set the name, and so I've positioned myself sort of on line 4. And so I print out fruit constructor. And then I print out pineapple. And that's the end of line 4, or that's the end of line 24. So I'm done line 4, and then I'm done line 24. I'm back in main, and now I print out main 2. And actually, I should have also made a note on the scope of the if statement that it's special because I've created a smart object inside of it, an object of type fruit, that will need a destructor to run when the scope is destroyed. So I print out main and then 2. Line 26, the scope ends. When the scope ends, this thing has to get destroyed. Before this thing can be erased, I have to call the destructor. So I call fruit destructor. So I begin erasing the scope to signal to myself that I'm doing so. Maybe if I leave the stars, it'll make it clear to me that I'm in the process of currently erasing this scope. Okay, so I'm in the middle of erasing the scope. I erase the only variable that was created in the scope is B. So I call fruit destructor. And then I print out pineapple. Okay, and so that's now done, and so I finish erasing the scope. The members of the class can now be destroyed. We'll see in a future video what happens if the members of the class themselves have destructors that need to be traced. We won't worry about that right now. Okay, so I'm back in main, I'm on line 27, and I create another object of type fruit. Now this time maybe I can copy and paste. There we go. Okay, so I made a second object of type fruit. Its name is going to be C, and the name member is going to be set to pear. And of course, in all the copying and pasting, I will remember to actually call the constructor. So I call fruit constructor, and I print out pear. And then the constructor ends, and now the object is fully constructed, and I can get down to line 28, which is main 3. And then main ends. But I'm not done, because main is a scope that needs special treatment. It has things in it that need to be destroyed properly. So I'll do what I've been doing already, which is I will erase the box but leave the stars to make it clear to myself that I'm in the middle of something. Now, in this case, I've got 2 things in the scope, both of which need to be destroyed, both of which have destructors. And as came up in a previous video, when I have a bunch of objects that get constructed in a scope, the destruction order is always the reverse of the construction order by a special case of the law of socks and shoes. If I put my socks on and then my shoes, I take my shoes off first. So in this case, C was created second, so it gets destroyed first. So I call the destructor for it. So I sort of begin destroying the object. I leave in the name and remove the box to indicate to myself I'm in the process of disassembling this object. And so I print out fruit destructor pear. And then the destructor's over, so I can now fully destroy the object. And then I get up, and there's only one thing left to do, which is to destroy this, and so I can skip ahead there. I don't have to do too much strategic erasing. Fruit destructor. And then I print out raspberry. And as I said, generally, when you have a bunch of objects in the same scope, they will be destructed in reverse order if they're allocated the way we always do, so with local variables. Later in the course, we will see there is a way of allocating them differently, so not the way we've been allocating stuff the whole course. Later, we'll see there's a secondary option that lets you take complete control over the lifespan, so you can decide exactly when something is destroyed. It can be in any order that you want. But for now, we allocate local variables. They are deallocated according to the law of socks and shoes, so we deallocate the most recently allocated thing first. Now, in a nested scope, so of course B is allocated before C in this program, but B gets deallocated first, it gets destroyed first because it's in a nested scope and the scope ends, and when the scope ends, we have to destroy everything in it. So we'll see in the next example, it's another variant of this, so also working with the fruit class, that does some tracing involving constructors and destructors, but also deals with interesting cases like what happens when a bunch of scopes end, for example, when exceptions get thrown.